So the total field for the capacitor is sigma upon epsilon naught. Why? Because no flux is going out of the capacitor, that we have already calculated. All the flux is inside the capacitor. All the flux is inside the capacitor. No flux is leaving out. So total flux is sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught, which becomes sigma upon epsilon naught. So none of the flux is leaving the plates of these capacitor. So total flux become sigma upon epsilon naught. So total field. So for first case it is 0, field is 0. For second region it is again 0. Now for third region the field is simply sigma upon epsilon naught. Sigma upon epsilon naught, and when we put the value of sigma is equal to q by a, that we know sigma is equal to q by a, so this becomes q upon epsilon naught a. So the electric field is localized between two plates is uniform throughout. So what we are saying, that the electric field between these two plates is uniform, that its intensity is uniform. Why? Because we have taken infinitely large or very large plane sheets. If we would have taken small sheets at the corners, there would be some problem at the corner, there would be some bending on the corners, but we have taken very large sheets, so there is no bending. And all the field lines, let us say this is positive plate, this is negative plate, so electric field is uniform throughout. For d square less than a, so that we have already seen that the distance square between the plates is much smaller than the area. The effects can be ignored in the region sufficiently far from the edges. So what they are saying, that this field is again uniform, only at the boundaries, edges it is not uniform, but since we have taken this area to be much larger, so we can consider this field to be uniform. Okay, now for uniform field, let us calculate the potential for uniform field. Potential is simply the potential is equal to field into distance. Potential is equal to field into distance, and this field we have calculated q upon epsilon naught a. So let us take 1 by epsilon naught this side, qd upon a. Here also this again qd upon a. The value of this E is qd, but is q upon a, and this epsilon naught is constant. Now let us calculate the capacitance. Now let us calculate the capacitance for this. So what was the capacitance? Capacitance was simply q by v, and value of v is 1 upon epsilon naught qd by a, and this is divided by, this is q divided by v. So let us solve this. C is equal to q upon, what is the value of v? 1 by epsilon naught. So this epsilon naught goes upwards, epsilon naught, this qd downwards, and a also goes upwards. Q and q cancels out, so this is simply epsilon naught a upon d. So as we have known previously, this is not dependent on any other quantity, only depends on geometry. So as expected, depends only on the geometry, area and distance between the plates. For a typical values, let us take area is equal to 1 meter square. Area is quite big and distance between them is 1 millimeter. So we have two plates which has area very large, 1 meter square. Okay, so another plate is just below it. There is another plate which is also 1 meter square. This area is not the area of two plates, this area of one plate. This is area of one plate. So if you add total area is 2 meter square, but we always take the area of either of plate, either plate. So this is 1 meter square. So area is 1 meter square and distance between them is 1 millimeter. So here you can also see that 1 millimeter square, the d square, which is 1 into 1 millimeter square, is much smaller than the area. Area is quite big because you know 1 millimeter square is equal to 10 to power minus 6 meter square. So d square is much smaller than the area of the plates. So let us calculate the capacitance in that case. C is equal to epsilon naught. Value of epsilon naught is 8.85 into 10 to power minus 12. Now area 1 meter square and d distance 10 to power minus 3 meter, because millimeter is 10 to power minus 3. Remember, this is a square. I am saying this to be d square. So d is equal to 1 millimeter equal to 10 to the power minus 3 meter. When we square this, d square is 1 millimeter square, 1 into 1, or 10 to the power minus 6 meter square, which is much smaller than this. So now calculating this is 10 to the power minus 12. So just cancel this out. So there are only 9 powers remaining. So 8.85 into 10 to the power minus 9 farad. So even if you take this much big capacitor which has a plate size of 1 meter square and distance between them is 1 millimeter, the capacitance is in nanofarads. In real life, capacitors cannot be this much big. Do you have ever seen this much big capacitor? No. So capacitor is which is connected to your fan, they are much smaller. They are somehow 3 or 4 centimeter, 5 centimeter. They are typically 3 or 4 or 5 centimeters capacitor, round capacitors connected to your fans. So 1 farad is too big unit. 1 farad is a very big unit in real life. So let us take much smaller units, nanofarad or microfarad. So these are practical units. So now let us see that how big 1 farad is. So again, let us calculate how big 1 farad is. Now capacitance is 1 farad. We take capacitance to be 1 farad. And plates are 1 centimeter apart. D is equal to 1 centimeter. Let us calculate the area. Area when capacitance is 1 farad and distance between the plate is 1 centimeter. What is the area? So rearranging this formula. So formula is epsilon naught A by D. So this is area is simply capacitance D by epsilon naught. This is area. This is rearranging. So now A is equal to C D upon epsilon naught. So capacitance is 1 farad. Okay. Now D is 1 centimeter. This time it is not millimeter. It is 1 centimeter. So distance between plate is 1 centimeter. 10 to the power minus 2 meter. Epsilon naught 8.85 into 10 to the power minus 12. When we put all the values, area is 10 to the power 9 meter square. See this area, 10 to the power 9 meter square. So again you can see this area is quite big, very big. And in real life, if you see, this is an area which is 30 kilometer in length and 30 kilometer in breadth. So getting this area is like a plate which is 30 kilometer in length and 30 kilometer in breadth. So this is a very big, and this is not practical. This is not a practical value. Hence we never use farad. What we use is microfarad or which is 10 to the power minus 6 farad, or nanofarad which is 10 to the power minus 9 farad. We never use farad. For solving, we use this farad term with appropriate power like minus 6 or minus 9, but in real life this microfarad or nanofarad capacity is far more useful. Now we have seen the capacitance, but till now we have considered dielectric was not there. We consider vacuum to be dielectric or air to be the dielectric. Now we will see the effect of dielectric on the capacitance.